National 5, it's another walk with Mr. Bull this morning, and today we're at Linn Park, if you can recognise that little map over there. And we're going to be talking about projectiles today. So I'm going to go down to the river, everyone's favourite river in Linn Park, the White Cart River. And we're going to throw a couple of stones, hopefully Nova going into the water as well. So let's go for it. Nash 5, I'm going to be talking to you a little bit about horizontal and vertical components of projectiles. But first of all, I'm going to show you an analogy before we do anything else. So I'm going to chuck some stones in the river and we're going to see what happens. Let's do this. Right, National 5, we're in a little bit of a quieter spot. I think some of you live in here. I think this is the Stampeland Way, so some of you might actually live quite close to here. But anyway, what I was saying and why I showed you me throwing some stones into the water was because there's two components when we talk about projectiles. One is the horizontal component, in which there's constant horizontal velocity, and the second is a vertical component, which is constant acceleration due to gravity of Earth, 9.8 meters per second squared. Now, when I was throwing those two stones, the analogy I wanted to show you was in many questions, something is thrown horizontally and something is dropped. Now, they will hit the ground at the same time because acceleration due to gravity is the same for all objects. So do not get confused when it asks you for the time, because the time is just the same for both. Alright, and hopefully when they're side by side, they kind of half showed that. Alright, now guys, this is wonderful. I've not seen this Stampeland Way until like literally this weekend, and I'm absolutely loving it. So if you live near here, then give me a shout. Alright, guys, what another good video on projectiles and actually satellites as well. But I'm going to go to the past papers, or the PowerPoints I should say, in 3, 2, 1, and go. National 5, welcome back, and I hope you enjoyed the little walk with Mr. Bull again this morning, this time at Linn Park. Yeah, today we were talking about projectiles, and I showed you that little analogy, and I hope that does help. We're going to talk a little bit more about it now, and also adding on to that, we're going to talk about satellites. Now, like, share, and subscribe. We are currently at 291 subscribers. We're only 9 away from 300. See if we can get to 300 by the time we come back. That'll be winning, basically. So if you are not watching this video and you've not subscribed or clicked that bell, do that now before anything else, alright? And that's your homework done. No, it's not. But anyway, let's move on. Projectiles and satellites. So today we're going to talk about projectile motion and then go on to satellites, both linked. Now, first one, projectiles, alright? If an object is fired horizontally, the force of weight pulls it down. It has a path called a parabola, okay, or just a curve, which is a combined effect of the horizontal motion and the vertical motion. Two different components that I was talking about. The horizontal motion, which is a constant velocity, and a vertical motion, which is a constant acceleration. Therefore, why when you throw something, it gets pulled down by gravity, but it's also moving in some sort of direction. Now, we can obviously have two different independent or component motions. One is horizontal, one is vertical. We can have two different equations to help explain both. So constant velocity has zero acceleration because it's just thinking about it in the horizontal plane. So therefore, all we need to use for horizontal is distance equals speed times time. It is super easy for horizontal motion. For the vertical though, we have the A equals V minus U over T. Now I'm going to come on to a question in a second where we actually use the equation V equals U plus AT, which is exactly the same as this equation here, just rearranged for V. Because often the questions that are asked is to find out the final velocity. But we know there's a constant acceleration acting on the ball as it falls. Alright, so those are the two equations that are very, very important for you to know. So, as it says, and again, the format here is always a nightmare when it goes from PowerPoint to Google, but when solving projectile questions, you should create two lists of information, right? One for horizontal and the other for vertical. All right, so the lists are for the horizontal with the underline v, d, and t, so like speed, distance, time, and for the vertical, u, v, a, t. Okay, initial, final, acceleration, and time. And if we were just to put information in, the initial will always be 0. Okay, why will it always be 0? Because it's always starting off on the top of a cliff. We're not going to higher yet where that won't be the case, but it's always going to be starting off at 0. And then the acceleration is always going to be 9.8 meters per second. So we've already got 2 of the 4 things that we want to find out in terms of vertical component. So, sometimes once you go on from that, and again we're going to show a really good example in a second, it asks to find like the vertical distance or the vertical height from which the projectile is thrown. To do that, we need to do a speed time graph. Okay, so if it ever asks you in a projectile question to find the height of something, you're going to have to first of all do a speed time graph. Okay, so to do that, you would be doing d equals area under speed time graph, and then the graph will look like that. You've seen these things before, and you'd just be doing the area under that. So it's not going to be a difficult calculation because it's just going to be a half base times height because it's a triangle. But be aware that that is what you'll have to do. You'll have to construct, and normally, sometimes it actually asks you to construct a speed time graph before you do it. Sometimes it doesn't know, so you need to be careful when that happens. So let's look at an example. Okay, it says a flare is fired horizontally out to sea from a cliff top. The speed of the flare is 40 meters per second. The flare takes 3 seconds to reach the sea. So, number 1 is what is the horizontal speed after 3 seconds? And then 2, calculate its vertical speed after 3 seconds. Okay? So, looking up here, flare is fired horizontally out to sea from a cliff top. The speed of the flare is 40 meters per second. So, horizontal component is 40 meters per second, which means that no matter where it is in the journey, it's going to be 40 meters per second. So it'll be having a nice curve. No matter where it is in that curve, it's going to be travelling horizontally at 40 meters per second. Obviously, as it said in the question, not including any air resistance or friction. Okay, calculate the vertical speed. Well, as I said, the vertical speed is going to be v equals u plus at. Now remember, we could have gone back and we could have done the list here and there. I have not done it in this one, but if you need a little bit more help with that, then do the list for the horizontal, do the list for the vertical, and see how to do it. But for the vertical speed, you should always know it's going to be v equals u plus at. Always, always, always know that. 0 plus, obviously, the initial, because remember it's at the top of the cliff, so it's not going vertically anywhere. The acceleration is 9.8, as we know, because that's the gravitational field strength of Earth, and the time is 3. So 9.8 times 3 is just 29.4 meters per second. Okay, 29.4 meters per second for the vertical speed. Now, that's 2 quite simple, straightforward questions that they can ask you that I'm expecting everyone to know. Okay, remember, pause it if you need to pause it and look over it. 3 says calculate the horizontal distance after 3 seconds. So remember, horizontal, we're thinking distance, speed, time. So all I'm going to do this time is do 40, because that's a horizontal speed. Remember, horizontal component times 3, which is 120 meters. Okay, just as I was talking about, remember, just as I was talking about in the park, the time it takes for the horizontal and the vertical, it's still the same time. The time's not going to change. The time is always going to be the same as well. Okay, and the time it took for the stone to drop down straight and drop down if I was throwing it horizontally would again be the same. Okay, because gravity is always acting the same on each object. Now, for 4 and 5. Draw a graph of vertical speed against time. So remember, I've said sometimes they might ask you that. Sometimes they might just ask you 5, which is calculate the height of the cliff top. And you would have to go back and do a speed time graph. So let's go to how I would do this. Well, I know that the vertical speed is 29.4 and the time is 3 seconds. So if I did a velocity time graph, the velocity is going to be 29.4 at the top and 3 seconds on the x-axis. And I'm going to draw a nice big kind of gradient line because I know that it's getting faster, and I'll stop at the 3. Okay, and then once I do that, and then obviously I've done the graph, so then I need to find out the area under the graph to find the total height of the cliff. It's just going to be a half base times height because it's a triangle. So half of 3 times 29.4 is 44.1. Okay, so you can trust my maths on that. So 44.1 meters, that's quite a high cliff. So 44.1 meters, and now that is exactly basically all the questions they can ask you in terms of projectile motion. Okay? So that's how you do all those. Now, so a little summary. Horizontal motion has a constant velocity. Vertical motion has a constant acceleration. Always compare the following lists, okay? Unless you're confident, like I showed you, you should be doing horizontal underline VDT, so you can do distance, speed, time. And then for V, UVAT, to therefore find V equals U plus AT, or equivalent. And then for anything vertical, you need to do a velocity time graph. All right, and then find the area under that graph. So this is an important slide. Take a screenshot if you need to, and then make sure you know all that stuff. Right, but then that goes us on to satellites. Not number 1, that's my mistake. Number 2 for satellites. Satellite motion is an extension of projectile motion. So obviously when we said that projectile motion is me throwing something with a horizontal speed and it then going to the falling to the ground. Now what happens if we were to throw something at such a speed that because it was going so fast, it never actually hit the ground? Now that is basically what satellite motion is. So satellite motion is something when we say things like floating or floating in mid-air or any other way to describe being in space, okay? And you say something like float, it's not correct physics, it's wrong physics. And I'm going to explain why that is and what we should be saying when we have questions like that. So satellites are constantly falling towards the Earth in orbit. That is the same as astronauts. Astronauts are constantly falling towards the Earth in orbit, okay? So that constantly falling is a key phrase that you must know. The reason why they're not falling to the Earth, though, is because they have a great enough horizontal speed that keeps them from falling down to the Earth. Okay? So they remain in orbit and do not move closer to the Earth because they have a great enough horizontal speed. So they do not move off into space because there's a force of gravity towards into the Earth. So the gravity of the Earth is still keeping them in orbit, but they're not moving towards the Earth because they have a great enough horizontal speed. So those are the two things that sometimes get asked. Great enough horizontal speed, and they're constantly falling towards the Earth. Okay, but both of them combined gives you an orbit. Now, one thing that you need to know is actually geostationary satellites, and sometimes these come up in questions. So geostationary satellites stay above the same point at Earth at all times. This allows them to easily send and receive signals, as we know exactly where they are situated. So if you're looking up in the night sky, you would probably need an app to tell you, but you could probably spot the geostationary satellites. Okay? So a geostationary satellite will have a period of 24 hours, because obviously it's staying at the same position, so it needs to be with the same spin as the Earth, and an orbital radius of 36,000 kilometres. Okay, so it's 36,000 kilometres above the Earth. Satellites have numerous benefits. Their GPS, weather forecasting, communications, and so on. Now, you need to know that. You need to know that a geostationary satellite has 24 hours orbital time and a radius of 36,000 kilometres. Okay? Now, lots of things going on here, but let me just talk through why I've got so much information here, and then that's us done. Satellites exhibit projectile motion. Okay? Just like we said. They remain in orbit and do not move close to the Earth because they have a great enough horizontal speed, but they're constantly falling. Okay? And they don't go off into space because the force of gravity keeps them in. We know the benefits of satellites. Okay? We know the period of a satellite in a high altitude orbit is greater than the period of a satellite in a low altitude orbit. So if you were to go have something much lower than a geostationary satellite, the orbital period would be faster. If it's to further up, it would be slower. Okay? So geostationary satellites stay above the same point on Earth, as we said. This allows them to easily send and receive signals, and we know that it's a 24 orbital time and an orbital radius of 36,000 kilometres. Right, so that is satellite motion and projectile motion, both linked, both very important, both difficult questions in any National 5 paper. So I'm hoping that is going to help you with your past paper questions. There's some really good in-depth questions today that also have a little bit of forces chat in from last week. Everything seems to merge into one, so you can't quite get a question that's just projectiles. Okay, but give it your best shot and have a good go at it. Guys, we're getting through this. Space is happening next week, and then that will be us moving on to energy after that. Well done, National 5, and I hope you enjoyed the video.